So in the previous video, we have seen about the degree of freedom in the turning pairs. So here we want to find out the degree of freedom in the turning pair along with the sliding pair. The figure shown here is the slider crank mechanism. Here we want to find out the degree of freedom for this given mechanism. So here A is the fixed link, A is a joint, and 2 is a crank, and 1 is a fixed link, and 3 is a connecting rod, and 4 is a slider. So here you have 4 links. So L equal to 4. And coming to the joints, joint should be named in alphabets. So A is a joint connecting 1 and 2. B is a joint connecting 2 and 3. C is a joint connecting 3 and 4. And D is a joint which connects 1 and 4. So here 4 links, 4 joints, and no higher pairs are there. So for degree of freedom, we want to substitute in the equation n equals 3 into L minus 1 minus 2j minus h. On substituting, we'll be getting n equals 1. So here we can check the answer. When there are even number of links, the degree of freedom will be odd, and when there are odd number of links, the degree of freedom will be even. So here 4 links are there, so the degree of freedom should be odd, so n equals 1. So the answer is correct. Determine the degree of freedom for the given mechanism. So all the fixed links should be taken as 1. This is the rule. And we want to name the links. So 1 is a fixed link, and 2 is a binary link, and 3 is a binary link, 4 is a binary link, 5 is a binary link, and 6 is a slider. Coming to the joint, so here A is a joint connecting 1 and 4. It is a binary joint. Similarly, B is a ternary joint. It connects the link 4, 3 and 5. So B is a ternary joint. So this ternary joint equivalent binary joint is 2. Similarly, C is a binary joint which connects the link 2 and 3. And D is also a binary joint which connects 1 and 2. E is a binary joint which connects the link 5 and 6. And F is a slider joint which connects the fixed link 1 and the slider. So here the joint is 7, higher pair is 0. So the degree of freedom is 1 for this problem. Here also the number of link is even, so the degree of freedom will be odd. State whether the linkages shown in the figure are mechanisms with 1 degree of freedom. If not, we want to make the suitable changes. We can either add or remove the 1 links from this problem. So here, looking into the problem, you can tell there are 12 number of links and number of joint is 16. So all are binary joints. So there are no higher pairs are there. So the degree of freedom will be 1 for this problem. The same type of problem. Here fixed link is 1 and 2 is a slider which moves vertically, and this is a link 3, this is link 4, link 5, link 6, link 7, link 8. It is scissors mechanism. So here you can see there are total number of link is 8, and all joints are binary joint, and here you have 1 sliding joint. So total number of joint is 10 with higher pair is 0. On substituting in the equation n equals 3 into L minus 1 minus 2j minus h, we will be getting n equals 1 for this problem. This is another problem. Determine the degree of freedom for the mechanism shown in the figure. By looking into this problem, we can tell there are 2 sliding pairs here. Here 1 and 8 and 1 and 2 makes 2 sliding pairs. Here you can see joints. This is a slider, 3 is a binary link, 4 is a ternary link, 5 is also a ternary link which has 3 connection points. 6 is a binary link. 7 is a binary link. 8 is a slider. 9 is a binary link. And 10 is a binary link. 11 is also a binary link. 12 is a ternary link. So here all the joins are binary joins except the highlighted point in the green color. So coming to the total number of links, you have links 12 and equivalent joint is 15. The higher pair is 0. So on substituting, you will be getting the degree of freedom is 3. So even number of links, the degree of freedom will be odd. So you want to identify this mechanism. This mechanism is a hand press, and you want to find out the degree of freedom for this mechanism. Before going to this, you want to draw the drawing. Find out the fixed links. Fixed links should be named as 1, and this is a 2, so link with the inclination which has 2 connection points. 2, 3 is also a link, and 4 is a binary link. 5 is a binary link, and 6 is a slider. So totally 6 number of links. Number of joints is A. A is a joint connecting 1 and 2. B is a joint connecting 2 and 3. C is a joint connecting 1 and 4. D is a ternary joint because it connects 3 links, 3, 4 and 5. And E is a binary link, and F is also a sliding pair. So it connects 1 and 6, right? So here we have equivalent, total number of equivalent joint is 7. So with no higher pair, so H equals 0. So the degree of freedom for this mechanism is 1. That is, if you activate this handle, if you press this handle, the slider will move up and down. So the degree of freedom is 1. So you want to identify the mechanism. Another type of problem, you want to identify the mechanism and find out the mobility of the mechanism. So this is the working of a punch press. So here you can see this is a fixed link. So A is a crank which rotates completely. Similarly, B is a point joint which connects the connecting rod and the punch. So on the complete rotation of this crank, A will able to get the motion of this punch, reciprocating motion of the punch is the slider. So this is a coupler. Other name of this coupler is a connecting rod. So here we can draw the equivalent line diagram. So the fixed link is 1. So this is a joint O. This 2 is a link representing the crank, and 3 is a link representing the connecting rod, and 4 is the link representing the punch. So coming to the joints, here we have one joint O. Here A is another joint. B forms another joint, and 4 and 1 forms the sliding pair. So here you have 4 links and 4 joints with no higher pairs. So the degree of freedom for this mechanism is 1. So here this mechanism we have turning pairs and also the sliding pairs. So here we want to find out the number of links. The fixed link should be taken as 1. 1 has 3 fixed links, 1, and 2 is a binary link, and 3 is also a binary link. 4 is a slider, and 5 is a binary link. 6 is a ternary link which has 3 connection points, and 7 is a binary link, and 8 is also a binary link. So total number of link is 8. Coming to the joints, so here you have one binary joint connecting 1 and 2. So this is another binary joint connecting 2 and 3. So here you have ternary joint connecting 3, 4 and 5. So this is a ternary joint. So here it is a sliding joint where 1 and 4 slides each other. Similarly, here in this point is also a binary joint connecting 5 and 6. This is a binary joint connecting 6 and 8. This is a binary join connecting 1 and 8. This is a binary join connecting 6 and 7. This is another binary join connecting 1 and 7. So total number of equivalent joint is 10. So total number of equivalent joint is 10. So here we can take the equivalent binary joint for this ternary joint is 2. So coming to the higher pair, there are no higher pairs. So on substituting, we'll be getting the degree of freedom is 1. So this is another mechanism where you have sliding pairs and turning pairs. So all the fixed links should be named in number 1 and link should be numbered as 1, 2, 3 and join should be named as the alphabets. So number 1 is a fixed link. So here you have two fixed links, 1, link number 2, link number 3. 3 is a binary link. Similarly, 2 is also a binary link. Then 4 is a ternary link because it has 3 connection points. 5 is a binary link. 6 is also a binary link. 7 is a ternary link which has E, G and H, and 8 is a binary link, and 9 is a slider. So totally 9 links are there. Coming to the joins, it should be named in alphabets. So A is a binary join connecting 1 and 2. Similarly, B is a binary join connecting 2 and 3. Similarly, C is a binary join connecting 3 and 4. D is a binary join connecting 4 and 5. E is a ternary joint which connects 4, 7 and 9. Similarly, F is a binary joint connecting 5 and 6. G is a binary joint. H is also a binary joint. I is a slider joint. I connects 1 and 9. So I is a slider joint. J is a binary joint connecting 1 and 8. So you'll be getting total of 9 links and 11 equivalent joints with no higher pairs. So on substituting in the degree of freedom equation, we will be getting the degree of freedom as 2. Here you have 10 links and 9 binary joints and 2 ternary joints. So the ternary joints are highlighted in red color. The joint E where connects 8, 6 and 10. Similarly, the joint B connects 10 and 9 and joint F connects 5 and 6. So the total number of binary joints is 9 and ternary joint is 2. So total number of joint is 13. So the higher pairs is 0. So the degree of freedom for this mechanism is 1. So that indicates whenever there is a motion in the input link, there will be a definite motion for the output link. So here you can check whether there is a even links, the degree of freedom will be odd. When there are odd number of links, the degree of freedom will be even. Thank you.